Yeah, so lots to talk about with both of you. Other than this,
wait, we're live.
No.
Don't spill the beans, man. We're live to the whole world right now.
There's
Graham
no
just threw the curtain back. Or maybe he tripped over it.
Yes.
Pulled it down.
You ready, Matt? Are you ready?
Not really. Let's do it.
Okay, Brendon, you ready?
I'm ready.
Okay, here we go. Here we go. Wait, actually, I'm not ready. All right, I have my notes. Now I'm ready.
To count you in. It's too late for the countdown.
Scene one. Hello, dearies. Welcome to Undersampled Radio, episode 52. I already wrote a show name on this document, which is horrible, but I do want this show name to have some pun reference to the name Hall or the room Hall, because we have Dr. Brendon Hall on the show today.
Hi, everyone.
Hello. Hi, Matt.
Hi, Brendon. Hi. Hi, Brendon.
But before we get to Brendon, Matt, tell me about what's happening with the hackathon. Can I get a ticket or what?
You cannot get a ticket.
Why?
The hackathon's sold out in a week. It's getting fun watching the tickets go down. I know, it's pretty cool.
Congratulations to you and Agile for a successful enterprise series of events.
Yeah, it's exciting. It's nice to see something become kind of vaguely, popular with the few dozen people that are interested in it. There's already a waiting list. The waiting list already has 8 people on it. You can sign up for the wait list at I guess the Eventbrite link you will find if you go to our website. Go to events. Sorry, go to agilescientific.com and events. So I expect some places will come up. I don't know if all 8 will though, however, because people's plans change. So yeah, it's happening and people are coming. And I wanted to mention something else. Have we got time?
Yeah. All we're doing is holding up Brendon.
Well, exactly. So sorry, Brendon.
I've got nowhere better to be, guys.
Okay, so put the kettle on. I can't believe I forgot to mention this last time. I'm a little bit embarrassed by my forgetfulness. But right after I got back from Holes, we approved the final proof of 52 more things you should know about paleontology. The snappiest titled book to come out this year on a scientific subject. It's now available in basically Amazon's stores. I wrote a blog post about it a couple of weeks ago when it came out. It's pretty great. Like I would, even for non-paleontologists, there's some cool stuff in there. There's a couple of technical articles, but many of them are very chatty.
And next week we'll be having a contest on Undersampled Radio, and the winner will receive a free copy of the book.
Ooh. Yeah, sure. We can have 3 winners. I'll send 3 out.
Okay.
No, this is episode 52.
It is.
It's too bad. Yeah, we couldn't give away a free copy now.
Oh,
damn it,
Matt. Well, look, Matt, you come up with by the end of the show, you come up with a nice riddle or contest or something, and I'll ask you the question at the end, and that'll be the contest. So everyone, get out your pens. Hey, but in the meantime, are there any other 52 things books brewing?
But it's almost as if so yeah, there is actually, Graham. Thanks for asking. I don't know how you knew about that, but we are trying to, and this is at least the 3rd time that I've tried to get this book together. We're trying to get a 52 things you should know about geocomputing. So
Brendon, have you entered an article?
I have not, but I'm interested to know what I would need to do to contribute an article.
So, well, thanks for asking that very relevant and timely question. Go along to, believe it or not, Undersampled Radio doesn't have a... Oh, no, we do. We do have a GitHub group, don't we? Or no, we just have a repo on the Software Underground organization, I think, on GitHub.
It's incestuous, isn't it?
It is a bit. But if you go to github.com/software underground, there's a 52 things repo there that I know that sounds a bit geeky, but it's kind of, apropos, I think, in this case. And there's a description there of what you would need to provide. Basically, in a nutshell, there's short essays, 750 words max. If there's any figures, then you get less words, fewer words. If there's any code snippets, and I hope there are, you get fewer words. It all has to fit into one double-page spread in our little books.
Yeah.
And it's basically just about the middle space between. I'm just drawing a Venn diagram here. The middle space between rocks and computers, and that's the subject of the essays. And the ones I like best are sort of either a little bit provocative, or like they're not the sort of things you'd normally write about in a publication, like pub stories, I call them.
So I took provocative in a new direction, and I wrote an article about encryption because I know that Matt's focus in life is openness and releasing things to the public. So I figured instead of provoking the public, I would provoke Matt, and he actually. I think maybe I shouldn't count my chickens before they hatch, but I think he's actually going to put my article in the book.
Yeah, it's a sort of obfuscating, it's a pseudo openness, obfuscating data. So pretty much anything goes. That we're also trying one new thing with this one, which is essentially some kind of peer review, because take 52 Things Paleontology. It had two technical editors, Alad Martinius and Alex Cullum. So those guys read the essays. I read them all. My wife, who's not a paleontologist or geologist, but an editor, she read them all. So they were reviewed by a couple of paleontologists and by other people, but there was no process to send them out to independent reviewers or anything like that. So I haven't really been calling them peer reviewed because there hasn't been any process. We're going to try some kind of light touch on the peer review with this book. So I'm hoping that people who submit an essay will also read an essay or two and give some feedback to the authors. And you don't have to submit to read and give feedback. You can give feedback. It's all on the GitHub repo. So that's a new thing. Hopefully that works out. I think it'd be kind of fun and give the book a little bit more. I think, for academics that are writing in there, especially, they like it if it's peer reviewed, so they can kind of count it as a legit publication.
How about a 52 Things That Troll Matt sort of compendium?
That was my idea with the encryption thing.
Maybe that should be the contest to win the.
It'll just be a whole book about conferences.
And we have to get Matt to peer review the entire thing.
Why lectures are awesome.
So the links to 52 Things Paleontology and the call for 52 Things Geocomputing links are in the show notes. So if you're looking for either of those things, you can find them there. Today, as we mentioned, Dr. Brendon Hall is our guest, and over half of our audience, which is to say 3 people, already know probably who Brendon is. But if you aren't aware, he is the man who started the geoscience revolution.
Wow.
And what I mean by that is, Brendon, actually, Matt, you tell a story. You know it better than I do.
Yeah, well, it was. I don't think revolution is too much of a stretch. Brendon wrote the tutorial for the Leading Edge last year, October's edition, and was it only last year? It was, wasn't it?
It was last October, believe it or not.
Yeah, and did an intro to machine learning, and it illustrated it with a nice example from a small data set from the Kansas Geological Survey. And in the kind of review process, we hatched a plan to sort of basically throw down the gauntlet to Brendon's readers to see if they could beat his score. And he very gamely not only agreed to all this, but was, you know, part of like figuring out how on earth we were going to do that. And the rest is sort of history. And the SEG machine learning contest of 2016 was born. It was fun, right?
It was a lot of fun, yes. But I mean, you did the lion's share of the work for the actual contest. But it was impressive, I think, to everyone how popular it was, and you know what conversations it started. So yeah.
Totally, yeah. No, there have been people were presenting papers at EAGE and I think at other conferences too about their results, and
yeah, companies are even baking that into their offerings these days. So we're all excited about that.
What are you referring to?
You know, just EAGE had a stunning representation of the types of things that are possible when we all work together.
Yeah, there was a nice bit of PR. I can't remember whose stand it was, or maybe we shouldn't name it anyway. But the fact that I can't remember is kind of somewhat amusing. But anyway, yeah, someone had like a. I mean, at first I just did a double take and thought that's Brendon's figure, but I think they had actually adapted it to their method, if not their data. So,
but I mean, in the end, though, there was a couple posters there about it. There was a presentation here in Houston. I know the SPE put one on, and someone had referenced the contest and the article and so on. But that's the exact kind of thing that I wanted to see happen with this. And I think that's the whole point of the tutorial articles is, you know, here is how you do something, folks. Go out and innovate on this. And the contest was about building on each other's results and demonstrate the kind of innovation that's possible with really a tiny amount of data that was just put in a proper context and prepared for that kind of event like the contest.
Yeah. No, you're right. It is just a seed, and it really makes you wonder, like, what kind of things we'd see if that type of publication or that type of, you know, whatever event game was a more regular, more normal thing in our profession.
Yeah. I imagine we'll come back to this during this conversation because it's, you know, going to be a common theme, I'm sure.
Totally.
Especially as we're heading into the next machine learning hackathon. So yeah. So Matt, actually question for you, you know, you've seen, this is the second machine learning hackathon. And I was wondering, how long did it take the one in Paris to sell out?
That's a good question, actually. I'd have to go back and look at when I announced it. But I'm pretty sure that tickets were for sale before Christmas. Right. And it sold out, I think, roughly 2 months before the event. So tickets were on sale for at least 4 months.
4 months. And so I think it was because I bought mine in December. And yeah, so now they're selling out in 1 week.
Yeah. This is actually the third. This will be the third learning hackathon.
That's right. That's right.
How long did it take to sell out the first one?
The first one did not sell out.
Oh, it didn't sell out.
So, I was begging people to come right up until the last minute.
It was good fun though.
So what's that? The next one should sell out in what's 1/16 of 1 week. Are
they all just going to be machine learning now?
4 hours. Well, it's a good question.
Yeah,
it's obviously pretty sexy. People like it.
Yeah. So what's all going into that that's causing the popularity now of the hackathons per se? But you know, certainly it's a little bit the subject matter. But do you have thoughts on that?
Yeah, I don't know. I mean, it does strike me that we should probably run the experiment. Like we've been hatching a plan to do a hackathon at AAPG, so that'll be interesting because that's on machine learning. But it's outside of the quote unquote normal audience, right? You know, in geology, rather than having a lot of geophysicists around. So that'll be one version of the experiment. And then if in Copenhagen we use a different theme, right? Which I'd be nervous to do because I really want the Copenhagen one to be a big success, and so does Total. But if we choose a different theme, I guess we'll see if it's the event itself or machine learning that's the pull. What do you think?
You know, I think that from what I've been seeing, a lot of things have been happening. Of course, machine learning has been very trendy recently and has been continuing to be so. As it's become popular, as Google and Facebook have got a hold of it, there have been proliferation of libraries that make it really easy to do some of these things. They've really taken a lot of the heavy lifting out of the programming, and they make it so that scientists who are experts in geophysics, for example, can download these things and feed it their data and get some results. I think that's made it much more accessible as well, and people much more interested in it. So that's one thing I noticed when doing the tutorial article, is that back in 2004, I think, when they ran that class that had that class assignment, we're using a collection of sort of Excel macros and old whatever became before R scripts, and it was pretty complicated to get some results. And I think if you distill the code in the tutorial article down to just the machine learning code, it's maybe 10 lines of Python. You can get a trained model and some results out of. So that's happened also. And then I think that there's been a lot of machine learning gains in other fields. Geoscience has a lot of ripe problems for machine learning that haven't been tackled yet. And so people are excited about that.
Totally. Yeah, it strikes me that maybe there are some themes around. I mean, maybe we can try getting a bit more specific, or moving the spotlight kind of around the general big field of machine learning.
Right.
The one of the buzzwords related to machine learning at EAGE was data and open data.
Right.
And I quite like the idea of, rather than a programming hackathon, there's more of a kind of
let's make some quality data sets.
Basically, yeah. I mean, data munging's not that much fun, so I don't know how. Maybe there's a fun spin on that, but yeah, basically a data curation effort.
Right.
I think that could be. I mean, there's certainly the products of a weekend like that would be. I mean, we've already seen what the kind of ripples the few days you spent on that KGS data set have.
That's right.
Have had. So, I mean, I can only imagine what happens when you do that with 50, 60 people, right?
No, I completely agree. And I think that, on the subject of open data, so having been in the oil and gas industry for my post-school career, those words can strike a lot of fear into the hearts of oil and gas people, right? Who have typically drawn a lot of value out of having proprietary data and so on. And so, this relatively small data set from the Kansas Geological Survey, what was that, 9 wells or something?
Something like that, yeah.
Okay, that was it. 9 wells, with some simple logs on it. And, 7 of those wells had facies descriptions associated with it that we could use to train a machine learning algorithm. And 2 of them we held back for testing. And we had 40 entries, 40 teams or so, and 150 different entries from all across the world, a bunch of different ideas. It spun, look, there was, person years of innovation that went into that.
Yeah.
And it's an example that, I don't think that all data needs to be open. Certainly that's an unrealistic goal for the oil and gas industry. But some data needs to be open. And it would be great if that data came with, a problem around it and maybe some papers published on it where people could see how to use it and put it in context and have an easy way to compare their results with somebody else. Just, a few well-curated data sets will go a long way towards realizing some of the goals that industry has, the computer vision industry has realized with self-driving cars and so on. ImageNet, right? ImageNet has really revolutionized the deep learning landscape, and we don't have something like that for geoscience, really. So,
well, let's also keep in mind that there is open data in the oil and gas domain.
That's true.
But as Matt suggested, it hasn't been properly munged, formatted, collated, and then, as you suggested, it hasn't been sort of prepared for analysis. It hasn't been cleaned. So, yeah, I think it'd be cool that. So, SEG Wiki has some, a start on this, where they've got several open data sets collated and referenced, but that's it. That's the extent of it. So be nice to see. Maybe that's just a repository. I mean, maybe that's just an interface to get to the data. But it would be cool to point people in that direction who have the time and enthusiasm to collate and clean, whatever, 100,000 open well logs in Louisiana or something.
Exactly. Yeah.
Brendon, where are you?
Where am I right now? I am at my place in Houston, Texas.
Is that your paper on the wall?
That is a paper I presented earlier this year at the Lunar and Planetary Science Conference in Houston.
Give us the abstract.
Give us the abstract of that. So I have been I've been very fortunate to be working on a project with Sean Gulick he's a professor at the University of Texas in Austin, and he's a co-PI on this project that drilled the peak ring of the Chicxulub impact crater. So this is an international team of scientists that took 835 meters of core from the center of the Chicxulub impact structure.
Wow.
And and so at Enthought, we have some software called Virtual Core that can analyze and process core CT scans. So we met with Sean and convinced him that they needed to get this thing CT scanned and put them in touch with Weatherford Labs, who did the scanning. And then we processed all of the data. And so that poster talks about that processing. It was a dual energy CT scan, which means that they can actually calibrate it and turn the CT volumes into measurements of bulk density and effective atomic number.
Wow.
And so that poster just describes that processing and how we did the calibration. And then at the end, I actually have the preliminary results from a machine learning approach where I use the pixels of the dual energy CT scan as sort of the feature set, and had a geologist label a few of the clasts that are of rock that are in this very interesting section that sits on top of the crater that's full of all these clasts that were deposited from tsunamis in the minutes and hours after the impact. And it's this huge finding upward sequence. And so we're using a machine learning network not too far from the one I outlined in the tutorial article to automatically classify all the rocks in there, and then use scikit-image, a Python image analysis library, to automatically quantify the shapes and sizes of all those clasts and the angularities and so on. And they can tell a lot about the impact dynamics from that.
That's
so
pretty sweet.
It's been a gift to have been able to work on this, being in industry and getting to take part in this really excellent science project. So there's a documentary on BBC, if you'd like to see more about it, called "The Day the Dinosaurs Died." Fairly recent documentary.
And is that research ongoing?
Yes, it's ongoing right now. There was a big science paper that came out last fall, and I think they're working on a few more. And I'm working on building out that machine learning paper with Sean right now.
Right. Because your background's pretty, it's quite the sort of Renaissance guy. Like your background's pretty varied, right? You've got a background in computing and geoscience and engineering.
That's right. So I have undergrad degrees in mechanical engineering and computer science from the University of Western Ontario and in Canada, which is not too far from Toronto, if you're unfamiliar with the region.
Yeah, it's in London, isn't it? Western?
It's in London, Ontario. That's right. And then after that, I went to the University of California, Santa Barbara, and did mechanical engineering. So I kind of combined the two. I was interested in computers and aerospace, and I thought I wanted to get into computational fluid mechanics. I thought that was a good way to combine both of these things. And so that's what I did when I was at UCSB. And I was actually on a very interesting project that wasn't aerospace related, but rather studying geophysical flow, specifically how turbidity currents, which are these underwater avalanches that sort of carry sediment from the shores down the continental slope out to deeper waters and deposit sand out there. And we were doing computer simulations of turbidity currents and understanding how they transported sand around. How does it sort the sand? Where do the big sand grains go and where do the small sand grains go? And this project was funded by an oil and gas company. And not surprisingly, after I was done, deep water turbidites were a pretty hot area in the industry, and Yeah, so I went to work at ExxonMobil Upstream Research Center
Modeling turbidite flow?
Modeling turbidites, and what turned into modeling all kinds of flows that create reservoirs.
Very cool.
Yeah.
Tell us a bit about turbidite formation. So let me preface this by saying, if you haven't done it yet, look this up on YouTube, because it's freaking awesome to watch the density flow simulations that people have. Yeah. So it's my layperson's understanding that this sort of dense sediment rich fluid flows much like water flows through air, right?
That's right. That's right. It's not, yeah, it's basically like, it's a lot similar to an avalanche, and there's a lot of interesting physics going on there. These things can travel for miles and miles, and they can be huge. The Grand Banks earthquake kicked off a notoriously, famously huge turbidity current, and it's actually how they discovered that these things existed. And they were able to measure its progress by actually timing when submarine telegraph cables were broken as it proceeded. And Matt, maybe you've heard of this earthquake, because I think that a lot of Nova Scotia and areas in the east coast of Canada were hit by tsunamis as a result of this earthquake as well.
Okay. No, I didn't. Yeah. I mean, I'd heard of the earthquake and those telegraph cables, but I hadn't heard about any tsunamis. I'll definitely check into that.
Yeah. So these turbidites, which are the deposits left by these flows, leave a kind of a characteristic sediment deposit. You know, they have the flow characteristics are they're sort of strong for a while and then they die off, and that will have an impact on the grain sizes of the sand that are left on the bottom. So you'll have coarse sand at the bottom, fining upwards towards the top. And understanding that architecture and that heterogeneity and how it differs laterally is key to understanding the economics of oil wells that these things become millions of years down the road. And that was the effort of modeling that, to try and come up with digital outcrops, if you will, of these deposits.
What other kinds of flows were you modeling?
Fluvial deposits, so river flows, how they form deltas, how waves can rework the sediment and alter deposits and so on. Yeah.
So yes. Did you build geometries like basin structure and then have finite difference modeling to build out the flow itself?
Yeah, a mixture of techniques, finite difference in grad school. So in grad school, we were studying sort of the turbulent structure of these flows and how that can, alter the sorting patterns and so on. In an industrial context, you can't really simulate the turbulent structure if you're going to actually simulate things as big as oil reservoirs and basins and so on. So you have to start incorporating a lot of approximations to account for those small scale effects and so on. But yeah, it was those kinds of techniques, very numerical, heavy stuff. And so that was my introduction to geoscience from the engineering standpoint. And man, it was great. Working at a big oil company as a geoscientist is wonderful. I mean, in my first 3 years, I think I spent a total of 4 weeks in the field. I got to walk outcrops in Utah and West Texas with, the people who literally wrote the book on sequence stratigraphy and those things, and it was fantastic. If I knew beforehand how much fun geologists had in school, I probably wouldn't have done in engineering and computer science. But it was great, and so that's how I kind of became a geo guy, despite my every attempt otherwise.
Very cool. And so Exxon, that would have been in Houston, right?
That's right. Yep. Piece. Yeah, and that's what brought me to Houston.
Okay, so you've been there ever since?
Yeah, I've been here since 2009.
Right.
Yeah.
It's the place to be. How's the sort of mood there these days? Would you say it's turned around yet?
Yeah, so that's a good question. I'd say these days it's sort of cautiously optimistic or defiantly optimistic. People are really, so the last 2 years were pretty bad. Yeah. And for the industry here. But oil's come back up a bit and things have leveled off, and there's a lot of optimism in the air. it's interesting the way things have changed. I think that the people are looking at solutions like Python and open tools much more because they represent a significant different cost structure than a lot of software packages have. But I've noticed a renewed interest in increasing efficiencies, and people are really looking towards machine learning and AI, to use a buzzword that I'm somewhat uncomfortable with, as ways to realize those efficiencies. So,
and what efficiencies are we talking about? Human capital efficiencies, or
yeah,
just
that's
processing
right.
speed?
Can we? So on both sides, can we use machine learning to predict where to, how to complete wells better, how to design our completions? Can we put stages, our frac stages in a more intelligent spot to get more oil?
So this is the efficiency of optimization, not necessarily the efficiency of automation.
That's right. That's right. Yeah, I'm sure people are trying all over the place. But last week I was at the ERTech conference that was held in Austin, the Unconventional Resource Technology Conference. And data science and analytics are very popular in that discipline. It's, they drill a lot of wells and they take a lot of data. They have a lot of data from completions. They have a lot of data from the surface and cuttings and so on, geochemistry. And yeah, people are scrambling right now to figure out what to do with it. So it was an interesting place to be.
Yeah.
So what's happened? Where do we go next with ML, AI, data
What's
science?
next? So good question. So I kind of think about this thing in the short term. I think you touched upon it, Graham. The way we like to think about it at Enthought is not so much replacing or automating, roles or disciplines completely. We like to think about giving scientists tools to help them do their jobs better or more efficiently. Okay, so I talked about this core processing software before, and what that does is it looks at images, CT or visible light images of core directly, and extracts patterns and features from it, right? It'll look, can extract bedding patterns and look at the dip angle and, try and count the laminations and so on. And in an effort to make their jobs more efficient and perhaps reproducible even, right? Reproducible science is a big topic these days too. And when, geologists have to look at miles of core to try and describe it, that can get monotonous. And so designing tools for them to help them do their jobs better, I think a lot of short-term gains will be realized there, right?
Totally.
Yeah.
Don't we lose some interpretability in results if we just have some black box ML algorithm doing our interpretation for us?
So I agree with that. And that's why I think that we don't want to have a black box algorithm doing all that work. I think we want to give, I want to enable, I want to give scientists superpowers, right? I want to give them assistants that suggest things to them rather than relying on their interpretation per se.
Okay, so is the goal then to quantify uncertainty?
Yeah, that can be one outcome of that, right? Because machines are really good at, for example, doing a bunch of Monte Carlo simulations if you make some measurements. So they can definitely help with that kind of thing. Absolutely. So moving on from that, and I think we all can agree on this. At the Paris hackathon, right? The team that won, the Gangsters, used this generative adversarial network to learn how to do a seismic inversion, basically, right? Without actually knowing the physics of the problem. And that was amazing to me. I still haven't wrapped my head around it, but I think that there's going to be that kind of thing will become more popular in the future. I know maybe Matt, and we discussed this there. It was amazing to me how you can take, the input state of a system, okay, and show it the output state, and it essentially will learn the physics of that problem.
Yeah,
and,
well, sort of.
Yeah, I mean, I guess that's the golden question, isn't it? Is like, what does it learn?
Well,
does it learn the physics?
Right. So So direct, yeah, it's learning maybe a projection of that physics onto a lower dimensional basis thing or something like that. But I mean, to me, that's an interesting way of thinking about these tools. So not just manipulating 2D arrays, you know, of intensities that are images and so on, but can it, you know, replicate physics of larger systems? I'm not sure. So that's something that's kind of exciting to me, and I've been trying to read about that some.
Yeah. No, I mean, you know, our models of natural systems, natural languages, natural, you know, laws are approximations and probably certainly flawed. Do you know what I mean?
That's right.
And so yeah, for me, I think one of the big challenges of machine learning, the machine learning kind of research for the machine learning research community, is how can we understand the weights? How can we make sense of the weight matrices that are that represent the learned state of the model? And because if all it ever is a big giant pile of numbers, I think there's always going to be skepticism. But as soon as, you know, for me, the sort of enlightening thing about looking at these long short-term memory networks in recurrent neural nets is that you can sort of watch individual neurons and see when they fire, when they're looking at a stream of data. And when you start to see that, oh, actually they fire at things that I recognize as a human. Like, it's very difficult to describe formally enough for a computer what constitutes a quotation or a paragraph or even a URL. But these neural nets learn what constitute these things without knowing it, without knowing what a URL is or what it's for.
That's right.
And that's when you start to see, oh, actually it recognizes the same things that I recognize. It's just more consistent, more reproducible, with a better measured level of uncertainty than I can be as a human. That's kind of an epiphany, I think, that's right. You know, people in geoscience will have to go through. So if researchers can only ever show them, here's your trained network, aren't the outputs awesome? I don't think that's going to be enough. Unless the outputs are so remarkably far beyond anything we can do with people. I think people are just going to be not going to trust it.
So what if, I mean, if we explore that concept in a little more detail in the image space, because it's something we can sort of visualize. Would you say that it's enough to extract weight matrices to gain, you know, hidden information from latent spaces in the network, right? So like this, you know, extract weights and biases from networks to typify filters, like so-called, you know, call them filters inside of a network. Does that help? Is that enough? I mean, you can pull out latent information from a convolutional neural network, which gives you things that look like edge detection filters, eyeball detection filters.
Yeah. I mean, to me, the representations of convolutional network filters, where you start to see, where you sort of see edge-like primitives building up into geometries and things that say look like faces. You know, you start to be like, oh, okay, yeah, I get how that's working now. Like, I can see that the filters make sense to me. They're just very difficult to design and optimize, and that's what the neural network's really good at.
Right. So that was my question. So is it enough to know where these things are happening generally in the network, or do we need, in the sake of reproducibility, to have a quantification of how that training led those weights to exist?
It's interesting, right? It's like the whole is greater than the sum of its parts. We may have a handle on the constituent components, but the emergent behavior of the entire thing is kind of something more. And so what level, you know, what understanding do we need to gain before we have sort of comfort that it's doing what we think it's doing, so to speak.
Yeah, and so yeah, I'm not sure how I would answer your question, Graham. But I mean, I guess the snag could be that humans are already really good at recognizing faces, and a face is unequivocally a face. Like, we can find situations where we know for sure we're looking at a face. It's difficult to find things in geoscientific data sets, like in seismic, for example, where we know for sure what we're looking at in a natural data set anyway. So you can go and interpret, I don't know, let's say something that might be quite difficult to interpret perfectly, like a flower structure or some complicated tectonic configuration. But where's your measure of objective, like, I know for sure what this is and where all these faults go, and who knows, like, fine recognizing it on one section, but it's a three-dimensional thing. The filters may not look like anything we would recognize as useful. I think that's the problem. Same goes for, like, or maybe that's a too complicated example. In logs, say, look at log patterns, look at like Pete Vale's drawings of, different shapes of logs in the late 70s that we still use, of finding upwards and the barrel shapes and all this sort of thing. Maybe computers recognize other shapes that we don't understand process for. Right? We may have to rethink bits of what we think we know about process.
Yeah.
Which will be awesome and exciting, but will take longer.
Yeah.
Well, coming from a computer guy, Brendon.
Yeah.
What does the computing landscape look like in 10 years?
So that's a good question. It's a fun one, 10 years. Have we reached the singularity in 10 years? What's Kurzweil's current prediction for that?
I hope it's longer than 10 years.
Yeah. I'm not really a doom and gloom machine learning guy. Those guys are, it's fun stuff to read sometimes, but in 10 years, I think that, there's a few interesting trends right now. There's a lot going on in display of computer information and visualization. So the VR space is very interesting, and we're augmenting reality, so to speak. And so I think that will play a bigger role. I think our data visualization capabilities will be enhanced. And I think that'll be great for us humans, as Matt just pointed out, to help us understand how machines are viewing things and so on. And so I think in 10 years, there'll be a lot of advances there. I think if we have this podcast in 10 years, we'll be probably sitting around the same room and, feeling much more like we're in the same space as opposed to, looking at a screen.
Yeah.
Compute wise, in 10 years, I don't think that, I don't know. I don't think we'll be doing too much with quantum computers at that point. I don't know if we'll be writing algorithms for quantum machines yet. But, yeah, I imagine our prediction algorithms will be up there. Hopefully we have an image met for geology. Hopefully at that point, I'll be able to put my smartphone on a rock sample, and it will, be able to tell me lots of interesting things about it. I might be on a field trip somewhere and I can put my smartphone at an outcrop, and, perhaps it'll be able to identify some sequences or some packages or so on.
Very cool.
Yeah.
How was SciPy?
So good question. SciPy was great this year.
You guys are pretty involved in SciPy, right?
That's right. Yeah, we're we kind of organize it and are the main sponsors there. We have lots of other sponsors, of course. I'm actually wearing my T-shirt from SciPy 2017. You can just see the top of it there. Yeah, so SciPy is a busy time for Enthoughters, but it's an excellent conference. So if you've never been, whereas conferences are normally organized around a theme where, a scientific discipline, where all the people that attend there are geologists or planetary scientists or so on. SciPy, on the other hand, has a common theme of the tool set that everybody uses. So you get scientists from all kinds of discipline, and also, folks from Silicon Valley and technology people that are using the same tool set. And which is Python and the open scientific Python stack. SciPy and NumPy and now scikit-learn and all those types of packages. And so people who are enthusiastic about it tend to be very open about their science, and they tend to be very passionate about those tools. And so it's a really great vibe to be there, because you're with a lot of people who are passionate about the same things you are, and you can walk into a talk by someone who's an astrophysicist that has a Python package for calculating, the orbit and the thrust you need to put on a satellite to get, into Jupiter insertion orbit and so on, which is fascinating. And then, just be around people who are developing the tools that you're using every day, and you get to ask them questions and, see your heroes, so to speak. So it's a lot of fun from that respect. Went to some good talks. Catherine Huff gave a great talk on reproducible science. And so we mentioned this earlier, and I know Matt's talked about it a lot, and I hadn't really heard anybody make an impassioned talk about it before. And a lot of things clicked for me. I think it's a very interesting concept. I think as we move in the age of fake news and, easily dismissible stories, it's powerful to be able to take someone's results and, click a button and actually reproduce them for yourself and play around with that idea and validate it. So I really enjoyed that. And also the keynote on Friday was Sean Gulick from the Chicxulub project I mentioned earlier. And he gave a great talk and talked about the project and what he's doing with the CT scans and so on. And so the great thing about SciPy is all the tutorials, all the talks are all made available practically the day they're given. And so they're all online if you want to go and check those out. There's some really great machine learning tutorials from some of the scikit-learn folks, and deep learning tutorials and pandas tutorials and all kinds of great things.
Very cool.
It really is a fantastic. I mean, I've only been twice, but it's the best conference I've ever been to. Like, it's totally worth taking the week out and going sometime if you use Python at all. It'd totally blow your mind.
Yeah. So for next year's, there was some mention about a software underground directed session. So as the dust settles on this year and we get into next year, perhaps we can chat more about that. So stay tuned.
Yeah, cool. Yeah, I mean, Earth Science has been, I feel like 5 years ago there were 1 or 2 talks, and then 4 years ago there was a half session, and then 3 years ago there was a whole session. Yeah. And I think now there's quite a bit of Earth Science stuff happening at SciPy.
There is, yeah. I got to see Joe Kington, gave a really great talk. He's at Planet now, and everybody who's always answering the Stack Overflow questions I have, there, so.
Nice.
Yeah.
Brendon, what are you reading?
So, good question. I am right in the middle of Flash Boys.
One of Matt's favorites.
Oh yeah, it's very interesting, by Michael Lewis. Yeah, I've been wanting to read a book of his for a while, and the whole world of high frequency trading was quite new to me, and so I picked this up, and boy, oh boy, is it scary and interesting and shocking all at the same time.
Speaking of high frequency trading, you may have heard that Bitcoin has had a hard fork today, just hours ago, into 2 different currencies, Bitcoin Original, Bitcoin Cash.
That one of them's called Original Bitcoin Cash?
One of them is called Bitcoin. The other one is called Bitcoin Cash.
Oh, okay.
So this is a great question for me, because 3 years ago I did this Coursera class and I bought $20 worth of Bitcoin, which is now worth a couple $100 of Bitcoin. But it's been sitting in my Coinbase account, and this split came up. And so what's happened to my Bitcoin, Graham?
Oh, well, nothing. It's all good. It's all the same as it was. Unfortunately, in Coinbase, you don't have the benefit of gaining an equal number of Bitcoin Cash coins. That particular market exchange decided to not honor at least now,
Yep.
the currency.
Okay. And what's the difference between the two?
It is actually a new cryptocurrency. So it's based, it has the same blockchain up until the point of the split. But since that point, there's a new blockchain, and there are a couple of technical differences, but the main one is that the block size is not the same. I'm trying to pull up a screen share for you right now, where you can see what your Bitcoin's doing. There you go. So anyway, we've had a little drop today, but that's to be expected in any big change like this. And we will see shortly an increase again.
Yeah.
How do we get on Bitcoin? Oh yeah, what are you reading? Matt, what are you reading?
You literally just mentioned it out of the blue.
I'm very excited about this.
Flash boys. Oh, Bitcoin.
High frequency trading, yeah. My apologies.
No, yeah, I remember you mentioned that it was coming up, and I wanted to know what it meant. So you've answered that question. I must find out, I guess. I did set up a Bitcoin mine, I guess, on my computer in like 2011 or something, like years and years ago. I really hope it's still running, but I suspect it isn't.
Or you're a trillionaire by now.
Yeah, exactly. I wrote it down because I knew I wouldn't be able to remember the author. Okay, I'm reading. So I bought a little book called A Student's Guide to Waves, I think, when I was in the UK last. I think I mentioned before that I really like book shopping in the UK, and especially in Cambridge. There's some fantastic bookshops there. And I really liked it. I really like tutorial-like books that have nice illustrations and don't make too many assumptions, or ideally really no assumptions. I'd say these students' guides, I can't remember who they're published by, but they're aimed at sort of undergraduates, I would say. So, you know, they're not totally elementary. There's a few assumptions about mathematical methods and stuff, but really not much at all. And anyway, I just started working on GPR but really the first time on a sort of applied project. So that's been really interesting. So I bought The Student's Guide to Maxwell's Equations by Daniel Fleisch. And it's actually even better than the wavelets, than the waves one so far. Really enjoying it. So it basically just starts with, you know, basic field theory and Gauss's theory, and works up to Maxwell's equations, but peeling them all apart with like, here's why this is a dot product, and here's what this vector means, and this kind of thing. So it's really nice. It could be, if it was in color, it would be awesome. He's made a few shortcuts to make it black and white.
What about if it was a Jupyter notebook?
Well, yeah, I mean, if it was a notebook or if it was interactive, it would be spectacular. So I've been meaning to recommend it actually to, if Rowan and Lindsay haven't seen it already, and the Simpeg crew, right. Rowan Cockett and Lindsay Heagy, then I hope they see this book, because it's maybe I'll just send it to them when I've finished it. But yeah, it is definitely one of those books that I've read, along with a handful of others that I could mention, where I feel like, yeah, this should be a Jupyter notebook.
Yeah.
Yeah. Robson's, yeah, it's called The Student's Guide to Maxwell's Equations.
Maxwell's equations are some of the most beautiful I have ever seen. Do they go through examples, or does he just do sort of derivations development?
Yeah, I haven't got to any kind of worked examples yet, but I'm like, I think I've just finished chapter 1 out of like 14 or something. So far, it's all been kind of theory, but really nice kind of large equations, all annotated. You know, and I really like that. I remember Rowan Cockett did a really nice annotated equation in his tutorial from last year, and even nicer actually than the one in the book, because Rowan's is in color and goes a little bit further than this one does. But I really like that sort of method of unpeeling an equation. it'd be nice to see someone go through and do a lot of geophysical equations that way, you know.
Yeah,
like Fourier transforms and the wave equation, and start with Hooke's law, you know.
There's another 52 Things book coming up.
I think so.
52 equations.
So I am reading a book called Stuff Matters by Mark Miodnik.
Oh, yeah. You were reading this last time, right?
Yeah, I was like one chapter in last time. It's really great. It's a material science book written for a lay audience that with no technical background. It's really great. It's funny. I mean, it's almost written like a novel. I mean, it's engaging and it's a fun read, a short read. So I totally recommend it.
When was it written?
Recently. I'll click on this link that's in the show notes, and I'll tell you as soon as my internet loads this page. It was written in 2014.
Okay. So it gets into graphene and metamaterials and interesting stuff like that. That's cool.
Yeah.
Okay, Matt, give us a contest to win a free 52 Things More You Should Know About Paleontology book.
Okay. This is the closest I could get to a 52, a relevant problem.
Okay.
I expect most of our audience know what the main coins are in Canada and the US. The penny, 1 cent, nickel, 5 cent, dime, 10 cent, and a quarter, 25 cents. Same in Canada. I know there's a 50, but
do we have a penny still?
In Canada?
Yeah.
Well, it exists in theory, but yeah, it's being expunged, like
deprecated.
Yeah, everything is rounded now, Graham, to the nearest 5 when you buy something.
Cool. I like it.
Yeah. Anyway, so the challenge is to make $1 out of exactly 50 coins.
Any coins?
Yeah, exactly 50 of them, though. Now, there may be a corollary. Maybe you could, as a follow-up, I know there's a solution to that. As a follow-up, maybe you can make $1 out of exactly 52 coins. I don't know if that's possible. If I hadn't been talking to you guys, I'd have been sitting here trying to work it out. But let's make that the follow-up question, which may be impossible.
If they get the 50 coins answer, the first one to submit to us the answer to that query gets a copy of the book.
No, let's draw it out of a hat. Let's not make it a speed, because that.
Okay.
Who knows what channel people are going to use?
It's your book. Okay.
Yeah,
okay.
Yeah. We'll draw.
But
yeah,
if it's possible to make $1 out of exactly 52 coins, let's send them a signed copy of the book.
Ooh.
Yeah, I'll send you 2 books. How's that?
His and hers.
Brendon, it was great having you on the show. That was a great conversation.
Thanks a lot, guys. It was a lot of fun. Glad to be here.
Hopefully we'll see you again on Undersampled Radio soon.
That sounds great. And hopefully see you both in September here for SEG.
Yes, indeed.
Oh, yeah, definitely. No, and I actually forgot, because I thought we hadn't had Brendon on before, but he did make a cameo appearance.
I did.
On the Paris Roadshow episodes in an interview. So, just a little bit of Undersampled Radio trivia.
Yeah. Okay, audience, see you next week for Undersampled Radio episode something.